Let's now apply the distribution model and transform our trip vectors into a matrix. In order to do that, we're going to need the impedance matrix, the scheme tree, uh, the one that we estimated and then added terminal times and computed intrazonal times. Our friction factor table, that are several options of models or of distribution models to use. In this case, for this project, we are using a friction factor table. And our vectors. And our vectors happen to be in fields of our TAZ file, right? In this case, as an example, I only have home base work, but that's enough to show you how to do it. With these three files open, we can go to planning, trip distribution, gravity application. And before we proceed, I'm going to show you a little trick. If we select only the fields that are that interest us, or only the zones that interest us, which are the zones 1 through 6, and perform the operation, which is doing. Let's see what happens. Planning, trip distribution, gravity application. We're gonna use and so first thing, production and attraction data are in the TAZ table, and we don't want all features, we want TAZs. Friction factor table is this table here that we have. If if the table is not provided to you, you can build it using the data available on the website. FF time, or friction factor time, is this field called min travel time. It's doubly constrained. We have to respect both productions and attractions. And here we can do all purposes at once. So by adding purposes, I'm going to remove it because we only have home base work here to work with. Home base work. Production is in FHWB. Attraction FHWA. Again, very good to have the fields in order. And the impedance score that we want to use is total time. This is the time that was generated automatically by TransCAD, the travel time, but we want the travel time that considers also intrazonal and terminal times. Press OK, and let's save the matrix as I'm gonna use the standard name, the name that TransCAD gives me just for the sake of this example. Press save. It converged. Here we have a matrix 6 by 6. Well, if you want to see the report you can, but it's not necessary. Here's the thing. If we have only 6 by 6, at some point we're going to have to append 2 more rows and 2 more columns. And you can't really append rows and columns to a matrix. You have to recreate the matrix, which is not difficult, but it's going to take some time. So the best thing here, I'm going to close this matrix and do it again. Trip distribution, gravity application. I'm not going to use only TAZs. I'm going to use all features. And I'm going to redo the whole process. Choose the friction factor table. Everything comes automatic. Home base work. Method table. Total time. So TAZ, all records, friction factor table, min travel time, doubly constrained. Impedance matrix, the shortest path is the only one I have. No K factors. The purpose called HBW, friction factor is an HBW friction factor, and the impedance, the core, the matrix that we're interested in the total time. Press OK, and again I'm gonna save it as the standard time, just for the sake of this example. And here we have a matrix 8 by 8, which is a lot better to work with in the future. And of course we didn't have travels for zone 7 and 8, so they're filled with zeros. Okay, so now we have our matrix distributed. If we had done all three purposes at once, we would have 3 cores of this matrix, 3 layers of that matrix. We only did one trip purpose, so we only have 1 core. There you have a distributed matrix.